This is the next lesson in Unit 5-6. We're still working on proportional reasoning. And what we want to work on in this lesson is some material out of Box 6A. We want to talk about rates and unit rates. And specifically, we want to be able to recognize rates, use rates to solve problems, and know how to calculate unit rates and use unit rates to solve problems. So first, let's talk about what a rate is. And a rate is very, very similar to a ratio. A ratio compares two numbers. A rate compares two numbers that have different units. So it's the units that are key when we are looking at rates here. So for example, we might have something like 200 kilometers in 3 hours. So somebody's driving in the car, they go 2 kilometers in 3 hours. We're comparing these two numbers, 200 and 3, but the units are different. We're comparing kilometers to hours. This makes it a rate, not a ratio. Or we might go to the grocery store and we might buy 24 cans of pop, and so we'll put 24 cans, and this costs us $27. So we're comparing the two numbers, 27 and 24, but the units are dollars up in the top and cans down in the bottom. And as you can see here, rates are usually written as fractions, okay, with one thing over the other. Now, problems involving rates, we can solve them the same way we solve problems using ratios, by using proportions. So let's take a look at an example here. Kirsten's neighbor used 120 patio stones to build an 8-meter square patio. Kirsten wants to build a patio using the same type of stone, but wants her patio to cover 18 meters squared of her backyard. How many stones will she need? Okay, we first have to set up our proportion by identifying in words what two things are being compared. So we've got patio stones and meters squared of patio. So our rate is going to be stones per area, or stones per meter squared. So what are we told about her neighbor here? Her neighbor used 120 stones, so we'll have 120 stones to get 8 meters squared. And we can put the units in here, meters squared and stones. We want to set up the other half of our proportion here. So what else are we given here? Well, she wants her patio to cover 18 meters squared. So this is an area, so we can fill in the area over here, 18 meters squared. And we're asked how many stones. So the unknown that we're trying to solve for is the number of stones up here. And we're going to solve this the same way we did in the previous lesson. We're going to cross multiply, and then we're going to divide. So 18 times 120 gives us 2060. 8 times x gives us 8x. And then we'll divide both sides by that number, that coefficient that we see on the x. So we'll divide both sides by 8. And we'll get x equals 270. Now, what does that x represent? It represents a number of stones. So we can say she needs 270 stones. And it's always good in a rate question to put that final sentence, especially just to be clear on what the units are, whether this 270 represents meters squared or whether it represents stones. Okay, so let's do another example here. A Mazda Protege travels 120 kilometers on 8 liters of gasoline. How far will the Protege travel on 30 liters of gasoline? Well, let's set up our rate here. We've got 120 kilometers in 8 liters. So we can set this up as sort of distance to the amount of gas that's being used. And so we've got a distance of 120 kilometers, and 8 liters of gasoline is our rate. How far will the Protege travel on 30 liters of gasoline? Well, we're given 30 liters, which is clearly an amount of gas. So it's going to go down on the bottom. And what are we asked to find? We're asked how far, trying to find a distance. So that's going to be our x up there. And then, as always, we're going to cross multiply. 30 times 120 gets us 3,600, just punching that into our calculator. 8 times x gets us 8x. We can divide both sides by that coefficient, 8, and we get x equals 450. Punch that in. So what does that 450 represent? Well, it's going to represent a distance in kilometers. So we can say it will travel 450 kilometers. Now the next big thing you can use to do using rates is you can convert things from one unit to another, one set of units, because the units are very important in rates. So in these two examples, we want to convert each speed to kilometers per hour. The first one here, we have 4 kilometers in 2 minutes. So this would be kilometers per minute. What we want is we want to change it to hours. So we want hour down here on the bottom and kilometer up on the top. This is what we want to get to. Okay? So we have to ask ourselves, well, if we've got 2 minutes here, how many minutes are there in an hour? Well, there's 60 minutes. Now, if we want to go from 2 minutes to 60 minutes, we have to multiply that 2 by 30. If we multiply the bottom by 30, we have to multiply the top by 30 as well. So 4 times 30 gives us 120 kilometers. So we can go 120 kilometers in 60 minutes. But 60 minutes is just 1 hour, so this is 120 kilometers in 1 hour, or 120 kilometers per hour, which is what we wanted. So let's take a look at the next one here. We have 200 meters in 1 hour. What we want, of course, is kilometers per hour. That's what we want to get to. So the bottom is okay. We've got hours on the bottom, but we have meters on the top. So it's that meters that we want to change into something. So let's see. We want to get that meters into kilometers. So if 1 kilometer is 1,000 meters. So 1,000 meters, how can we get 200 meters to 1,000 meters? Well, we have to multiply by 5. So if we multiply 5 on the top, again, let's multiply by 5 on the bottom. So 1,000 meters is in 5 hours. Well, that 1,000 meters on the top is the same as 1 kilometer. So 1 kilometer in 5 hours. And we can do that division. 1 divided by 5 gets us 0.2 kilometers per hour. Okay? Where we just did 1 divided by 5 in here. Okay? And when we do this division, taking the number on the top and dividing it by the number on the bottom, this is what's called calculating a unit rate. And that's the next thing we're going to talk about here is unit rates. In a unit rate, the amount of the second quantity that we're comparing. Remember, a rate compares 2 quantities with different units, one on top, one on the bottom. In a unit rate, the amount of the second quantity is 1. So whatever that thing on the bottom is, it has to have the value of 1. So something like 100 kilometers in 1 hour. Or we usually write this as 120 kilometers per hour. Okay? As I've said right here, unit rates are usually written as a single number with a fraction for the units. Okay? So we take this and we write it as 120 kilometers per hour. Let's do another one here. Let's say you work, I don't know, you have a job and you get paid $30 for working 1 hour. This would be a unit rate, but we would usually write it as $30 per hour. This little slash here means is read as per. Which just means for each. So let's take a look at an example here. Brittany worked a 6-hour shift each day for 4 days and earned $612. What is her hourly wage? Well, her hourly wage is going to be a unit rate. So we want the amount that she gets for 1 hour of working. So let's see, how many hours did she work? She worked 6-hour shift each day for 4 days. So she worked 4 days times 6 hours is 24 hours. Now we can set up our rate. She earned $612 in those 24 hours. And to calculate the unit rate, we just have to do this division. We just want to take that 612, divide it by the 24, and that is going to give us our answer in dollars per hour. So we punch this into our calculator. 612 divided by 24 gets us 25.5, and as we said, dollars per hour. So that's how much she'll be paid each hour. So how much will she earn if she works 40 hours over March break? Well, let's see. She works 40 hours, and she is paid $25.5 each hour. So if we just take her unit rate, $25.5 per hour, multiply by 40, that'll tell us how much she gets paid in total for those 40 hours. $1,020. Okay. The very last example here is probably the most frequent application of unit rates that you're going to see here. Okay? And I've said here, unit rates are very useful for making comparisons. Okay? So let's take a look at an example here. Northern Lights Fireworks operating costs are $620 for 8 hours, while Forest Timber's operating costs are $585 for 6 hours. Determine which company has the greater operating costs. To answer this, find the unit rate for each company. We've got a bunch of numbers here. We've got $620, we've got 8 hours, we've got $585, we've got 6 hours. Those numbers are difficult to compare because they're for a different amount of hours. So we want the amount for the same number of hours, or in this case, we can find the amount for 1 hour by calculating the unit rate. So let's do Northern Lights first, and I'll just say for NL, their unit rate is going to be $620 divided by 8 hours. And we're just going to do that division. 620 divided by 8, we punch that into our calculator, and we get 77.5. So that's $77.5 per hour. Let's do Forest Timbers next. So Forest Timber has $585 in 6 hours. So we calculate the unit rate, just doing that division, we get $97.5 per hour. So now we can clearly see which one has the greater operating costs. It's Forest Timber, because it has the larger number here. So we can say Forest Timber's costs are greater. And we're done.